Hello, also from my side. I'm Andrea Damiani, just completed my last year PhD with Professor Sant'Ambrogio here at DABE, and I work on reconfigurable hardware architecture. So let me go straight to the topic I've been researching for the last 3 years, and the core of the topic is Golden Tree, which is a fully automated hardware development toolchain for creating hardware accelerators that can bring what the machine learning does, machine learning inference does, usually on the cloud to the edge. So it is similar to what a colleague said before as an objective. This is necessary, moving everything from the cloud to the edge when we want to create intelligent solution, because more and more practitioners, people, researchers are asking the question, can we trust a brain that sits on the other side of the internet? Can we trust its availability, its reliability, and so on? Because nowadays, and since the beginning of the colonization of machine learning into a lot of application fields, such as smart homes and automotive sector, and also now portable health devices, what happens is that everything that thinks is in the cloud. The machine learning has to use the sort of unlimited or almost unlimited resource availability that the cloud offers, and sensors are just collecting data from the real world, streaming them to a cloud server on the other side of the internet. There our brain thinks, and that brain sends the information back to the actuation layer. This of course has allowed a super important growth of machine learning in the last few years, but has a lot of drawbacks. The main problem here is that we have the internet in the middle, and when we use the internet, response time is not something we can ask a guarantee about. We will never know how long it will take for our brain to answer our query. Then we add on top privacy problem and managing everything centrally from the cloud, and this is not a scalable solution. So the solution to this is, of course, moving everything to the edge. And this is kind of a simple solution, as it looks like, but it's not a solution if we really think about what is the real problem in going from cloud to the edge. We use the cloud because of its unlimited availability of resources. And in edge devices, in small, tiny devices in the real world, we have hundreds, let's say, a lot of orders of magnitudes less resources available. And even if we can manage to squeeze our brain, our machine learning model to fit these tiny devices, then it's a really complex task to program them to exploit hardware acceleration, and it takes years of expertise in a completely different domain from data science and data engineering, which is usually designing the models. So the real solution is to build something that is fully automated, yes, yet highly customizable, and it's a hardware development, both flow and tool chain, for hardware acceleration to bring machine learning to embedded heterogeneous devices. So the advantages of doing so are related to the fact that we can exploit hardware acceleration, which means that we can squeeze every single drop of performance out of the limited amount of resources that we have on embedded devices, and we can do that fully automatically, which means that we do not leave out all the experts in model design, in machine learning, algorithms, and so on, because they just need to supply their model, and in a few lines of code, we generate automatically the hardware accelerator for them. Yet, we do not want to leave out the experts in hardware design, in hardware acceleration, so we want to build something that is highly customizable in order for them to extend it and to integrate it with other tools. So this is exactly what N3 does, and it does it for decision tree ensemble, so it's not for everything. It's for a specific class of model which is well known for being highly explainable, which is an important trend, as the previous speaker said, and it's doing this by exploiting partial dynamic reconfiguration on embedded FPGAs, which are hardware devices, hardware architecture that can reconfigure their circuitry while they are running. The data scientist has to only supply their model, and then everything is completely automated till we can reach the hardware. The project now is going towards two different evolutions. First of all, we are working on extending our methodology, but we also want to increase our TRL level, bringing this to real-world application, which is real-time drivers aggressiveness characterization. We started already having a small POC on that, and that has been my research in 5 minutes or so. Thank you so much for your attention. These are my contacts if you have any other questions, or otherwise I'm here. Thank you so much.